Hello, this is Mr. Gbamu Idanogbene. You are welcome to our lesson for week 6, which is on circle. We are going to focus on perimeter and area of a circle. It's a very short topic for the week. Now, we have done our CA, we have done our revision of the CA question. As I promised, I will send the video of the revision of the CA question and also the CA question to this platform before we go for midterm break. So latest tomorrow, see everything in our platform so that this weekend, which is your midterm break, you can use it to go through the question. So let's start our lesson for today, which is perimeter and area of a circle. Today we are going to look at this following objective. Everybody should be able to identify part of a circle, and I'm going to focus on these 4 parts, which is the center of a circle, the radius, the diameter, and the circumference. Then we should be able to know how to measure perimeter, which is also called the circumference of a circle. So take note of that. We should be able to use our formula to calculate circumference. We should be able to use formula to calculate area. Then finally, we should be able to solve simple questions on perimeter and area of circles. So that is all for today's lesson. Very quick and fast. Let's go now. Now, this is the part of a circle. Now, looking at the circle, we already know how a circle look like. We have so many examples of circles. We have cylindrical object. When you look at the top is a circle. Your tin of milk, the top is a circle, just like that. In your houses, we have shapes that have a circular, that are circular in nature, like most of our plates. Most of our plates are circular plates that we use in eating, and so forth and so on, like that. All right. So now how do you define a circle? This is a simple definition of a circle. A circle is a plane shape with all points equidistant from the center. I will demonstrate this definition as we move to the next applet I have for us. So every point on this circumference of this circle, they all connect to this center and they all have equal distance. That's what this word means, equidistant. Now, looking at that, what is now this point that is dark at the middle? So this is the center. So what is the center of a circle? So the center of a circle is the fixed middle point. So this middle of the circle which connect the radius to the circumference, you can see it, and also connect the diameter. You see the line that crosses through the center of the circle is the diameter. So this center is very important when it comes to circle. So this is what we call the circle, is the middle of the circle. That is the middle point, and it's always fixed. You can't shift it from this place. Diameter can be drawn from anywhere, radius can be drawn from anywhere. You will see as I demonstrated in the applet, but center can never be shifted. It's just here, and from here the circle can get bigger or smaller depending on the size of the radius. The radius, which is small letter r, is always the distance from center to circumference. So you can use this formula to calculate radius. So divide diameter by 2 is equal to radius. So radius is diameter divided by 2. Then diameter, which is mostly used as small letter d, is the distance across the circle through the center. So you can see it, the distance that crosses the circle through the center. And we always use this formula to calculate diameter if we know the radius, which is 2r. 2 times r, 2 times radius, will give us diameter. Then circumference is just the perimeter of the circle, which is this curve around the circle. So you can see the circumference is the same thing as perimeter. It's this curve that goes around the circle like this. So take note of that. So let me show us the applet as we continue the notes. All right, so this is the popular applet I use in class. So you already have the link to this applet. Now, let me start by creating a slider. You can actually do this at home. So just watch this video where use your laptop, download this applet from the link I will place, then play around with these things on your own. As you click on slider, put your increment. I want my radius to increase by 0.1. I want it to increase to like 10. So the maximum I can increase my radius to is 10. And the minimum is 0. That means a single dot. There's no radius. Now let me change this A to R. Since I want it to be my radius, just click on OK. We are through with that. Then let's get our point. So this is the point. So this point, let's label it. I want to label this point. Let's use letter O, since that is what I used to define it in our notes. So let's use letter O as our center. So this O is the center of the circle. Now let's get our circle. So this is circle with radius. I want this one. So I click on this. So the radius, I use small r to define it. So type your small r there and it's okay. So with this, I can generate my circle using this slider. You see now that is 0 is just a dot, which is the center. As I'm increasing the radius with this slider, you see the circle is getting bigger. So this is one thing you can demonstrate that too. But now I want to introduce the radius. I want to put it there. Now get a point. We say a circle have a center point which is equidistant from everywhere around the circumference. So if this is a point, this point have equal distance around the circle. You see, as I click and drag, it's going around the circle. So the distance to the center is equal. And that distance is what we call the radius, which is this. And I can label this my point and this my line. Let's rename it. Let's call it radius. So that is the radius. So you can see it, the radius. So this radius will keep being radius anywhere this point goes around the circle. See the way I'm going around, just like that. And this point can never move. This is a fixed point. Even if I click and move it, the circle will move with it. It's fixed. You can't shift it from this position. But radius can be shifted. You can see I've shifted it now. It can be in anywhere, but it must be equal around the circle from the center to the circumference of the circle. So this is radius. Now, if I want to get my diameter, let me get a straight line. So I need a line through the center of the circle that will pass through the circumference like this. Then let me just create only the diameter. Let me create an intersection point like this. Okay. Then let me create the segment from this point to this point. Yes. So let me hide these ones outside. I don't need these ones outside. Just right click and click on this to go. Now this is my diameter. See, I can click and move around. So you can see my diameter. It can be the same line with radius, which is radius will now be the half of the diameter. See, the diameter is from this point through the center to this point. So you can see the diameter can go around just like this. So you can actually play around with this when you get home. Settle down, get the link of this applet in your Google Classroom, click on it and play around with this like this. So this is radius. Then finally now, let's do our circumference. I've told us that circumference is the curve of the circle. So if I move from this point round this circle, let me put it somewhere here. Put it somewhere here. So let me change the color so that you will see this color of the circumference. Just click on it, come to this place, click on any color. Let me use blue color. You can see it's blue. I can increase the thickness if I want. But I don't want that. I want only the curve, not the inside. All right, so this blue line, see this blue line is my circumference of the circle. So this is my circumference. Just the curve around the circle. This place that is blue is the circumference of the circle. So take note of this thing I'm doing. You can actually play around with these things when you get home. You can increase the radius, you can make it big, you can make it small, just like that. You can move the diameter to anywhere. Diameter is always diameter as long as it passes through the center. Then circumference is this blue line surrounding the circle. All right, let's go back to our notes. Okay, let's minimize. All right, so this is part of a circle. I've explained it with the applet. Now, how do you measure the perimeter of a circle? Say measuring the perimeter of a circle. So to measure perimeter of a circle is very easy. Just take a thread or a string or any rope that is flexible. Take it round the circle. You can take it round your cylindrical water bottle or your tin at home. Anything that is round, take a rope round it. Then by the time you take it round, straighten it, make it long, then take it to a ruler and measure the length of the rope. Then this length is what we call the circumference, which can also be called the perimeter. Let me demonstrate it also with this applet here. Now you can see this applet. You see my circle. This yellow curve is the circumference now, which represents a rope. So this is a yellow rope around this circle. So just make sure you know your diameter from the center of from one end through the center of the circle. So this is my diameter. So in this case, diameter is 4. So by the time I open the rope now and straight it, Just click on this unroll straighten. You see the rope is being straightened now. So this is the value of the circumference. So just let me zoom it. By the time you open it, put it on ruler, you see it's between 12.5 and 12.6. That means the diameter of this, the circumference of this circle is 12 point, let's just say 12.58, something like that. You can take your pen, you can write it down. Okay, I don't have a pen here. You can take pen and write it down, which is 12.58. This is how you measure perimeter, which is the same thing as circumference. Just take note of that. I just want to use this applet to do some demonstration. You can actually change so many things you want to change. You can change the diameter if you wish. You can change it to any value. Just click and drag. You can rule it, measure it on your ruler, just like that. That is how you get your circumference. So by demonstrating this, you have known your circumference of your circle. So that's what I mean by measuring perimeter or the circumference. Take note of this explanation. Then now, what is pi? This is very, very important when it comes to circle. How do you get the value of pi? In our calculation, we usually use 22/7 for convenience sake. But actually, the pi is gotten by dividing circumference by diameter. Now, we all already know how to get the circumference of a circle. That rope that goes around the circle, stretch it on your ruler. The length you get is your circumference. Now, divide that circumference by your diameter. It will give you your pi. Let's do the same thing in the same applet we just finished using just now. Let's get the applet again. Okay. So this applet is what we used just now. Okay, our diameter, you can see this is 6.5. Let me open the rope now. I'm opening it. I've placed it here. So the diameter is shown there, 6.5. This is the diameter. Now let's get this length. Let me zoom it so that we can view it well. Now if I zoom, let me zoom again. If I zoom it now, the length of this rope is giving us 20 point. See, very close to 20.4. Like, let me say 41, 20.41. That means if I divide this 20.41 by 6.5, I will get approximately 3.4, 3.14. That is what that formula is trying to say. Let me try it with my calculator in the system because of time. Let me use this my system calculator. If I do 20.4, let me say 41. If I divide it by 6.5, the diameter of that circle, you see it gave me exactly 3.14. You can see it. Let me go back. You see 20.41. See, it just exceeded 4, very close. Divided by this diameter, that is your pi, 3.14. That is what this place is trying to do. Circumference divided by diameter is giving us 3.14. It's an approximate value. It's an approximate value. Let me just do one more demonstration. Let's change the diameter. If I change the diameter to, let me say, okay, let me change diameter to 4. Let me roll it and see what it will give. So I've rolled it now. Let's stretch and see. You can see the applet. Let me show us the beginning so that you understand. This is the roll. I've rolled the applet. That means I've straightened the rope. If you straighten the rope, go and check the measurement. So this is 12 points. It's between 12.5 and 12.6. So if you do 12 point, let me just say 12.6. It's just the middle of 12.5 and 12.6. No, let me use 12.56. Let me use 12.56 or 12.55. Let me use 12.55. You know, it's an approximate. That's why they say it's approximately 3.14. If I divide 12.55, let me use 12.55. Let's use our calculator first. So 12.55 divided by 4. No, I use diameter of 4 this time around. Let's be sure. I use, yes, the diameter is 4. You can see diameter equals to 4 units. So divided by 4, let's see the answer. You see, it's giving us 3.134, 138, which is approximately 3.14. We have done approximation. If you approximate this to 2 decimal, your answer will be 3.14, 3.14. So take note of that. So this is how we get our formula for pi. So for easy calculation sake, this pi is being discovered that is constant for all circles. So for easy calculation, mathematicians choose 22/7. In case you are asked to do any calculation, you know 22/7 will be much better and much easier to solve than 3.14. So that is why we advise to always use 22/7 when calculating. But actually, pi is approximately 3.14. Take note of that. So let's move now. Now, these are the formulas. You see, formula for circumference is easy now. You already know what I did just now. If the, let me get my pen, if pi, which is this symbol now, is equals to, let's take C as circumference divided by D as diameter. This is what we did just now. So you know now, if I cross D to the other side of this equation, if I cross D to this other side of the equation, I will see C will now be equals to, remember, divide will turn to multiplication, will now be pi D. Don't forget that. Now be pi d. Remember the other time I said diameter is 2 times radius. So if I take away this d out of this place, c will now be equals to, remove d and put 2. Then put your pi followed by your radius. So these 2r represent diameter, then pi is the constant. So this is how we got circumference of a circle, which can also be called the perimeter. If they ask you to calculate perimeter of a circle, which is p, it's the same thing as the circumference. So don't forget that perimeter of a circle is 2 pi r, just like the circumference of a circle. They have the same definition. So this is all for the circumference of a circle. Then area of a circle, you can see it. So area of a circle is gotten from pi r square. Let me just demonstrate this very fast using this applet. I have one applet I used to show us. So this is the applet I'm talking about. This applet will help you to understand how the area of a circle came into existence, which is pi r squared. Now, if you study this applet very well, you will discover that this is a circle. It's divided into 24 equal parts. You can change the number of divisions here and say this is 40 equal divisions. You can reduce it to 6, which is the smallest I have here. But let me do something like 12. Let me divide it into 12 equal parts. So you can see the circle is divided into 12 equal parts. If you observe very well, each of these parts is a smaller sector. So you can see something like triangle. Now let's try something. You see this place, I've already strengthened the circumference. You know what it means now? That means as I cut the rope that goes around this circle and strengthen it, just like what happened in that ruler in the other demonstration I did. You see, so this is the circumference of the circle. Now, if I cut this circle now and open it, watch the way I'm going to cut it. Something like this. You see the way I'm opening the circle. If I open the circle all through to the end to this place, you will see that this is the circle now, based on the area now, is equals to the circumference of this circle. That is the length of this circle now is equal to the circumference of this circle. But this height, you see the height is the radius. But this shape does not really look like a common shape. I can easily use my formula. This is so many triangles. We have about 12 of them because it's divided into 12. So what I'm going to do now, I'm going to fold this blue part now. I'll fold it on top like this. Just watch. By the time I fold it on top, you see the way it's going up, it will now land on this other side. Now, this is a shape that we all know. Looking at this shape generally, it looks like a parallelogram. This is a parallelogram. And now, based on our knowledge of parallelogram, let me get my pen. You will see that this is our base. From the knowledge of parallelogram, this is base and this is the height. See, this is the height. And we remember what we said in parallelogram. We said this height must be 90 degrees to the base. So this is the height. Now, this height, if you discover, is equal to the radius. Now, the circle from this point to this place is the radius of the circle. You can see, let me remove the pen. Let me click the radius, you see. So even the system will record it as radius. So radius serve as the height, then this is the base. Now, if the circumference of a circle is from here down to this place. Now I've removed the circumference, I've cut it into 2. Now this is half of the circumference. That means if a circumference of a circle, remember the circumference of a circle, see, in our last explanation we said is 2 the circumference of a circle is 2 pi r. But now I need half of it, which serve as the base of this place. So half of it means you should divide by 2. Then if I cancel it out, so this circumference that is divided by 2 now gives me half of pi r. See, which this place becomes pi r. So the base of this parallelogram that is formed by this circle after I make it into a parallelogram now is pi r. Now, what is area of a parallelogram? If I want to get the area, I will now say area, which is A, is equals to what? Is equals to base times height. And my base in this place is pi. You can see it, my base is pi. Then multiply it by my height, which is radius, which is equals to radius. By the time you multiply this, you see that A will now become pi r times r, and r times r will give us r squared. So this is how the formula of area of a circle is being generated. You can see it. The area of a circle is pi r squared. The area of a circle is pi r squared. It actually came from a circle that is divided into smaller sectors. Then by the time you fold this sector into a circumference, something like this. Let's go back so that you see it again. This is a circle. I divided into 12 smaller sectors. By the time I open it into a circumference, you see, then I now fold half of it. So this is half of the circle, and now fold half of it into a parallelogram. So now what is area of a parallelogram? That is base times height. Since this full length is a circumference, divide it by 2, that is pi r. Now pi r serves as the base, then the height is the radius. Area of a parallelogram is base times height. Therefore, area of a triangle in this case is going to be pi r times r. Then pi r times r will give us pi r squared. So this is how the area of a circle is being generated. I just want you to have all this knowledge. They are very good at this our level, JH1. By the time we have this knowledge, you don't need to be memorizing formulas. This applet, as I said, is always with you. You can play around with it, practice with it. It will help you to understand mathematics better. As you grow higher in maths, you begin to understand it in your own way. So that is what I have to explain about the area of a circle. So let's continue with our lesson for today. So this is the area of a circle, pi r squared. Take note of this. So pi is always 22/7 or 3.14, but I always advise we use 22/7. So this is all for today's lesson. Let's just do one simple example, and that is all. You see this example, it says find the circumference and area of this circle. So without wasting time, we have proved the formula. So circumference is 2 pi r. So don't have time to waste. Then area is what? We have done the formula. Area is equals to pi r squared. So area is pi r squared, which is r raised to power 2. Now, if c is 2 pi r, so just do your normal multiplication 2 times. As I advise, use 22/7 for pi. It's easier, except the teachers tell you to use another one. But if they not tell you to use anything, use 22/7. And radius is 7, just put r at 7. Then if it's area you want to calculate, it will now be 22/7. 22/7 now times what? Times your radius raised to power 2. Let's erase this. And radius in the question is 7. That is 7 raised to power 2. 7 raised to power 2 is the same thing as 7 times 7. So you know now 7 cancel 7, leaving area to be what? Area will now be equals to 22 times 7. 22 times 7. And when you do 22 times 7, what will it give us? So let's times it and see. This will be 4 remainder what? 2 times 7 is 14 remainder 1. 2 times 7 14 plus 1 again will now be 15. So your answer will be 154 centimeter square. The area must take that square. Then circumference, 7 cancel 7, which remains 2 times 22. And 2 times 22 will give us what? 2 times 22 will be 44. So circumference will be equal to 44 centimeter. So this is all for today's lesson. Go through the video, go through the notes, you will understand how area and circumference of circle is generated. Play around with the applet and you will understand it better. Now you can play with this classwork, do this simple classwork, then do this assignment. This is all for this week. When we meet again next week, we do our we continue with this topic circle, but meanwhile, I'll send more notes and more explanation in the Google Classroom so that you can do more practice. Then the projects we are going to do, I'll send them in the Google Classroom as we go for the break. So thank you for watching this video. Do have a nice day.